Hello everyone, welcome back to Techniques by Kaushik Gantu. In this video, we are going to discuss about threads and its types. It's also often asked in interviews and it's one of the important topics. And interviews expect threads and multi-threading in the student project too. And a strong grip over this threading concepts is required. So let's just start with what the thread is first. Uh, a thread can be considered as a small unit of execution of some code, or you can call it as a lightweight process. Okay. A process can perform multiple tasks using threads. That's advantage actually. Multiple tasks can be performed. And one of the major thing here is they share the common resources more. Uh, like for suppose they all run in the same CPU, they'll have same memory. All the threads running in a CPU have same memory, and that's how. So there is a concept of synchronization. One of the very important topic in interviews, MCQs, and in projects too. That is synchronization. And then we had that's a one point, and then we had switching, which is also an important point to be noted. Like switching does not require OS help. No sorry, no OS help is needed. Okay. For the subprocessors or the process to switch between multiple cores of CPU or context switching that requires the OS intervention. But here we don't require the OS intervention. Okay. And regarding communication, communication are like between the inter-thread communication. Like if two threads has to communicate with each other, there are some procedures. You will have pipes and message queues and all, and the communication is more efficient here than the sub-processes or the processes. Okay, more then we there's a problem here. The problem is like if there is a blockage, like uh, like for suppose if one thread blocks because of the race condition or some deadlock, all the other threads will block. That happens in the process too, but we can kill them or we can solve them because there will be sometimes processes runs in different CPU environments, so one process do not affect the other process, but in threads they all run at common memory and common CPU. So if one blocks, all get blocked. And interestingly, every thread has a program counter. You know this one, right? In Java too, Java threads has every thread has a program counter, which is the set and tag space. When um, threads can be preempted, we know threads can be preempted, they can be scheduled, and we can kill them too. Hmm. They can be killed. Okay, let's jump into types of threads. Threads has there are two types of threads really, like kernel level threads and user level threads. Okay, let's first discuss about kernel level. What is kernel first? Kernel is part of OS. It's generally everyone knows that all the system calls and all the OS specific and critical tasks are done in the kernel space itself. Okay. Generally, there will be kernel threads run in the kernel. They are tracked by the kernel thread table. Uh, we call it as kernel thread table, and time management is based on thread count. So if there are more threads running in the kernel, then the time is managed based on the count of those threads. And generally, they don't get logged usually. If they get blocked too, the OS is there, so they can get manage. The OS can manage and it handles that. So what are the disadvantages here is basically uh, little slow but efficient because the OS is there, the context is same, generally do not have OS help in this, but it's in the kernel space, and kernel is more related to OS, so OS involves here. That's why it is little inefficient. Uh, I mean, it is little slow there. But regarding the efficiency of completing the task, the OS, since OS is there, it is more efficient in completing the task. And also, there is a small overhead that is to maintain a separate overhead of what to maintain a separate tables to track them. Tables and tracking those what are the memory it uses and what are the program counter and registers it is using. You need to track them in a table, right? So that is a little overhead that it has. Next is a user level, right? Yeah. User level threads can be uh, seen. Generally, what are the threads we create as user level threads? Generally, no system calls are involved here, and kernel does not know about the user level threads. That is interesting thing. So as per kernel thinks like there is only a single thread. But we are running multiple threads, right? As per the kernel point of view, there is it thinks everything is a single thread process, but we had different user level threads. What are the advantages we had is like we can implement OS and we can implement the multi-threading. Generally, all the projects that we do are user level threads, custom threads that we write, and switching is faster and there is no need of the OS, right? So there is the multi-threading in the projects and easy switching. Other advantages. And there are some disadvantages too. They are like no kernel interactions. Kernel interactions are important for fast communication sometimes. Uh, so that's why these days we had a hybrid approach, an HTN model and kind of thing. Java's implementation of some of the threads internally are having a different hybrid approach, combining both kernel and user level thread. Okay, but now we are confined to what is a kernel and a user level thread. Okay. Generally, the kernel interactions are there. So the advantages like fast communication and these system calls are not available here. Like we need to use again the kernel thread support there. And I write no here. Right? No. Um, then if one blocks, it creates a page called like so that everything gets blocked. That is the problem there. One blocks. So that's a major difference you can tell. If one block, all blocks. So, but in the kernel level threads, if one block, the OS will handle that and the other will not get blocked. It will have its kernel space to get allocated for the other one. So there will be no race conditions kind of thing or a common resource. The OS manages that. But here, if there is a one blocked due to a race condition or due to one common resource, every other one depending on that, all other threads will get blocked. That's the difference between user level threads and kernel level threads. And these are the possible interview questions. They'll ask what's the major difference between kernel and user level, what is a thread, and what are the multi-threading projects you did, and what is difference between thread and the process. I discussed uh, regarding the communication, regarding switching, and common resources and synchronization. Uh, these are the major areas you can tell where there is difference between a thread and the process. So these are the major interview specific questions that can be. Thank you.